Hi everyone, I hope you all are doing good. So let's start this tutorial with a very interesting problem, and the problem is smallest subarray whose sum is greater than or equal to target. So in this tutorial, first we will understand the problem statement, then we will solve this problem with multiple approaches. So let's start with the problem statement, and the problem statement is given an array of positive integers and a positive number k. We have to write a code to find the smallest contiguous subarray whose sum is either greater than or equal to k. And if no subarray is found, then we have to simply return 0. So let's understand this problem statement through multiple examples. So in the first example, we have given an array and the value of k. So the smallest subarray whose sum is either greater than or equal to k is this one. In this subarray, the two elements are 6 and 5. So now let's see what all possible subarrays we can form whose sum is either greater than or equal to k. So first subarray we can form is this one, in which, so let me mark it as well. So if you do the sum, its sum is 11. Now the second subarray we can form is this. So let's write its length as well. So the length of this subarray is 4. Now the length of this subarray is 5. The length of this subarray is 4. The length of this subarray is 3. And the length of this subarray is 2. And out of which this is the subarray whose length is smallest. So all these subarray, if we do the sum of their elements, its sum is either equal to k or greater than k. Now let's move to the next example, in which this is the input array and the value of k is 12. If we see, if we do the sum of these three elements, it is 8, and we have to find a subarray whose sum is either equal to 12 or greater than 12. So there is no subarray we can form using these elements. So definitely we have to simply return 0. Now let's move to the example third, and we have to find a smallest subarray whose sum is either greater than or equal to 7. So again, the smallest subarray is this, but let's see all the possible subarrays, what all possible subarrays we can form. So one such subarray is 2 1 5, and its sum is 8 and its length is 3. Similarly, we can form this subarray where the elements are 1 5 and 2. So we have to form the contiguous subarray. Now the next we can form is 5 2, and then we can form this 2 3 2. So these are the possible subarrays we can form, and out of which the smallest subarray is this one. So that's why the answer is 2. So this is the problem statement. Now let's think how we can solve this problem efficiently. Let's start with the easiest approach, and the easiest approach is to form all the subarrays of the array whose sum is greater than or equal to k. And to form all the subarrays, or you can say to explore all the subarrays, we need to use two for loops. So the outer loop, from the outer loop we pick each element of an array one by one, and from the inner loop we keep adding the element starting from the same index till it is less than the value of k. So what I mean is, let's say if the outer loop start from the 0th index, the inner loop will also start from the 0th index. When outer loop start from the first index, the inner loop will also start from the first index, and from that point we keep adding the element until its value till its value is less than the value of k. And whenever sum of elements is greater than or equal to the value of k, it means we have found the subarray. So we have to update the minimum length value, and once our iteration is complete, we have to print the minimum length, I mean the minimum subarray we have found whose value is greater than or equal to k. So let's see its code and let's visualize how this code is working. So initial here I have declared two variables. One is mean length to keep track of the minimum subarray length, and we have to find the minimum subarray length. So initially I have assigned the integer maximum possible value in mean length, and the second variable is sum whose initial value is 0. Now first we have to write the outer loop, and the outer loop start from the 0th index, and it will run till it will run it will visit all the elements of an array. And from the inner loop, so the inner loop will start from the same index. So if outer loop start from 0th, inner will also start from 0th index. If it start from first, it will also start from the first index. And in each iteration, so I'm talking about inner loop, in each iteration we pick the element which is present at the current index, we add them in the sum variable, and if the value of sum at any step, if the value of sum is greater than or equal to the value of k, then we have to update this variable, mean length variable, and after that we came out of this loop, and the flow of execution goes to the outer loop. So let's visualize this approach. So initially the value of I is 0, so j will also start from 0, and in inner loop the first element is 7, so the value of sum is 7. 7 is less than 11, so this condition is skipped. We increment the value of we increment the value of j, and the value present at this index is 2, so let's update the value of sum 9. Again this condition is skipped. We increment the value of j, and the value present at this index is 1, so we update the sum variable, and now its value is 10. Again the same thing, we have to skip this condition, and the value of j will be increment, and we pick the value present at this index which is 1. So let's update the value of sum which is 11 now, and it is equal to the value of k. So this line of code will execute, and the initial value of mean length is the integer maximum possible value, and the second value, I mean here we are finding the mean between the integer maximum possible value and this value which is j minus I. So the current index of j is 3, the current index of I is 0, and plus 1. So we have found one subarray whose length is 4, and the sum of the element of that subarray is greater than or equal to the value of k. Now after that we came out of this loop through because this break statement will be executed, and we came out of this loop and we go to the outer loop. So now the value of I is incremented to 1, and this value of sum is reinitialized which is 0, and j will also start from this index. So again the same thing happens, we pick 2, its value is less than 11, so the value of j is incremented, so new value of sum is 3. Then again this condition is skipped, we pick 1, so the new value of sum is 4. Next, in next iteration the value of j is incremented, we pick 6, so the new value of sum is 10, and in next iteration the new value of sum is 15. So this time this condition is true, and this time we are comparing between. So now the current value of mean length is 4, and here the current index of j is 5, the current index of I is 1 and plus 1. So the minimum between 4 and 5 is 4, so there is no change in this value, and we move to the outer loop, and this time the outer loop will start from the second index, and j will also start from the inner loop, will also start from the second index. So the first value is 1. So here you can see the value of sum is again reinitialized to 0, and this is 1. Then j value of j will be incremented, then again it is 2, then we move to 6, and then we move to 5. So after that, in this way, when we move to this, when the outer loop will start from this index, the inner loop will also start from this index, and when we see the first value is 6, so the value of sum is 6, which is less than the value of k, so it is skipped. Next, in next iteration, the value of sum is basically we take this element. When j is incremented, we take the value present at this index, and the value of sum is 11, which is equal to k. So we have to find the mean length. So the minimum between the previous mean length value and the current mean length, which is basically current, this one, this expression. So the value of j is 5, the value of I is 4, and then plus 1, so basically 2. So between this and this, it is 2. So basically between 3 and 2, the minimum is 2. And from where the 3 comes? So 3 comes when the outer loop points at this index. I mean, from before forming this sub array 6 and 5, in previous step we formed this sub array 165, and before that we formed this sub array 1165, which is of length 4. Now then we form a sub array of length 3, and now we form a sub array of length 2. So between 3 and 2, the minimum is 2, and after that we break we came out of this loop. Then in next iteration, I will move at this index, and j will also start from this index. And after that, I mean, when we add this value in some variable, it is 5, and 5 is not greater than the value of, neither greater nor equal to the value of k. And after that, this condition is false, so we came out of this loop, we move to the outer loop, and it is also came out of this loop because we reach at the last index. So after that we check whether the mean length is equal to integer max value. In that case, we have not found any sub array, we simply return 0, else we return the mean length. So we return the mean length, which is 2. So this is the brute force approach. Now let's talk about its time complexity. Its time complexity is big O of n square. And what about its space complexity? Its space complexity is big O of 1, because we are not using any extra space. So let's improve this solution and let's solve this problem in linear time complexity in big O of n in our next approach. In our previous approach, we have solved this problem by exploring all the sub arrays using 2 for loops. But have you realized we are doing a lot of repetitive calculation in inner loop? So let me explain. So in our previous approach, when we have used 2 for loops, so let's say when the outer loop start from 0th index, the inner loop will also start from the 0th index, and in inner loop we pick the elements till the value of sum is less than the value of k. So we pick, just I am writing it so that so we pick 7, we pick 2, we pick 1, we pick 1. So this is the first sub array, and when we do its sum, it is 11. So when I points to first index, j start from this index. So this time we pick 2, we pick 1, we pick 1, we pick 6, and we pick 5. And if I if we do the sum, it is 15. So when I points to 1, in that case we pick 1, 1, 6, and 5, and the sum is 6, 5, 11, 12, and 13. And when I points to this index, we pick 1, 6, 5, and the sum is 12. So I am talking about the calculation we are doing in the inner loop in our previous approach. When I points to this index in inner loop, we pick these two elements and we do the calculation. So if you see this part and this part, we are doing this calculation again and again. So if you see this part and this part, we are doing the calculation again. Similarly, you can see 165, 65. So this is where we can use a sliding window approach to improve our solution. And let's understand how we can improve our solution using a sliding window. Be with me if you don't know the concept of sliding window. You will understand it after this explanation. So here we are taking two pointer, start and end pointer. So initially both the pointer points at 0th index, and then we move the end pointer until the sum of the element is less than the value of k. So let's take one variable sum, and we move the end pointer till the value of sum is less than the value of k. So let's move the end pointer. So first the element present is 7, so the value of sum is 7. Then we move the end pointer and start pointer remain as it is. And now the element present at this index is 2. So let me add it, and the new value of sum is 9. And again its value is less than k. So let's move the let's move the end pointer and pick the value present at this index. Now the value is 1, and it is, let me add to the sum variable, it is still less than k. So let's move this end pointer, and end pointer is pointing at this index. So let's pick the value present at this index, add to the sum variable, and now its value is 11. So the value of sum is equal to the value of k. So the next step is to update the mean length. So initial value of mean length is the integer maximum possible value, and the index of start index point at 0th index, end index point at 3rd index. So let's compare the minimum between the integer max value and the end minus start, which is 3 minus 0 plus 1. So what it indicates, we found one sub array whose size is 4 and its sum is greater than or equal to the value of k. So let's update the value of mean length, and now its value is 4. Then the next step is to move the start pointer and pick the value which is present at this index and subtract it from the sum variable, and we have to move this start pointer till the value of sum is greater than or equal to the value of k. So the value present at this index, 0th index, is 7. So let's subtract it from the sum variable. Now the new value of sum is 4. Update the value of sum variable, let me write it sum, and increment the value of start pointer. Now start will points to the first index, and if we see now our sub array
will point from this index to this, and you see its sum is 4. So the value of sum is less than the value of k. So again we have to move the end pointer. So the start pointer remain as it is at points at the first index, and let's slide the end pointer, and end will points at this index. So let's pick the value at this index and add to the sum variable. So the new value is 10, which is less than the value of k. So let's move end pointer again, and the value is 5. Let me add to the sum variable, and the new value of sum variable is 15. So start is pointing at first index, end is pointing at fifth index. So let me update the mean length. So the previous value of mean length is 4, and the new value is 5 minus 1 and plus 1, so which is 5. So there is no change in the mean length, and the next step is to take the value present at the start index, which is 2, subtract it from the sum variable. Now the value is 13, and move the start pointer into the next index. So start pointer move to this index. So still this value is greater than, so here you can see we are using while loop. So still the value is greater than the value of k. So again we take the value present at this index, which is 1. So the new value of sum is 12. We calculate the mean length. So this time we have to calculate between 5 minus 2 plus 1. So you can see, so 4 comma 4. So again there is no change in mean length. So the next step is to move the start pointer by 1 index, take the value present at this index and subtract it from the current value. Let's subtract 1 from the sum variable, and new value is 11. But before that, let's update the mean length. So start pointer point at this index. So start pointer end pointer points the last index, start pointer points at this index, then plus 1. So basically the new value is 3. So the mean between 4 and 3 is 3. So mean length is updated. Then we take the value present at this index, subtracted it from the sum variable, and its value is 11. So still this condition, while condition is true, the value of sum is equal to the value of k. So next step is to again, start pointer will point at this index. So after subtracting the value, we are incrementing the start pointer, and this time we have to update the mean length. So the previous mean length is 3 and the new is 5 minus start pointer points at fourth index plus 1. So you can say the minimum between 3 and 2 is 2, and this time we pick the value present at this index, which is 6, and subtract it from the sum variable. So when you subtract 6 from the sum variable, now the new value is 5. And after this we came out of this while loop, and also end pointer reach at the last index. So we came out from this loop as well, and we return the mean length, which is 2. So the code is pretty simple. I have already explained using this visualization technique. So now you can see using single for loop by using a sliding window, we have solved this problem in a single loop. So basically we have leveraged the previous calculation while creating a window. So in this case, the window size is not fixed, it's dynamic, because it depends on us on the calculation, we have to expand our window till the value of sum is less than the value of k. And when our sum when the value of our sum variable is greater or equal to the value of k, then we move the start pointer so that we can contract our sliding window and till the value of sum is greater than k. And again, after that we move the end pointer to expand the sliding window. So in this way, we have solved this problem in big O of n time complexity, and also we have and the space complexity is big O of 1. So in this tutorial, I have explained two approaches to solve this problem, and that's it for this video tutorial. And if you please share this video with your friends and colleagues, and please don't forget to like this video and subscribe our channel. Thanks for watching this video tutorial.